Good morning. It's me, Pattern. What's up, everybody? Happy Sunday. So Sundays we're doing 3D modeling. We're doing Blender. I can't even call it 3D modeling anymore because we're past that. We're past that stuff. We're not modeling anymore. This we're doing now. We're doing materials. We're doing textures. This is the next step. And and yeah, I didn't get much thinking about how I wanted to get this done. So part of what we're doing today is figuring out how we're going to make these materials. So like I said, let me open up my notes. We've these are all the steps to get done in order for a VTuber model and avatar. Also, the same process for VR chat, literally same process. This is step by step of how to get things done. Granted, there are steps within the steps, and then there are steps, no steps, and probably even steps, no steps. It just goes on and on. Let's see. So this was the first step. This is actually a published video by now. And the first step is literally the design. We're just drawing it so that we have an idea of what to make in 3D. It's if you just dive into 3D, having an idea without having a reference of how to make something, it would be so much better to have a reference. So literally when I'm drawing in 2D, if it's on my tablet or on a piece of paper, I literally start with one line. I think it's called a line of action or like line of gesture or something. Literally a single line. Like that's the first step, is that very first line. And so the same premise comes with modeling in 3D, where if you want to make something, you gotta start before that. So we start in 2D, drawing. And yeah, that drawing takes a line. That line takes like a thought, right? Just you keep going like backwards and backwards until you find where to actually start. So that's what we did. We drew it, literally 2D. Literally, I'm sorry, not 2D. Literally, pen, like pencil and paper, and then I made it. And then I imported it to digital Procreate on iPad, and then that was finished. And then I threw it into Blender, through to 3D. But that was the first step, right here. Turning it digital, like literally drawing it, turning it digital, importing it to Blender was the very first step. The second step, creating the mesh based off of the drawing. So literally, like and then there are rules behind it, and all that was done 2 tutorials ago, so to speak, and it's right here. You know, like this was the drawing I had, some references on how to make a croissant, and we don't even need this anymore. We kind of do. We do. Actually, I'm lying when I say we don't need it. Because there's still colors there. Very basic colors, but it's something to start with anyway. Even if it's like a penny, it's better than nothing. And so that was the second step. The third step was making the UVs, which was a lot less time consuming than making the actual mesh. When I was making the mesh, I was taking UVs into consideration. So places like the paws, places like the paws, places like the paws, places like the ears. Like I made a loop and formed it a certain way before I even added these red lines, before I even added these themes, which was done as a part of the UV process right here. Create seams accordingly. You know, make the UV grid. Save as texture. Add part names in GIMP. I decided not to do that because, like, after working with this for over, what feels like definitely for over 10 hours, I know where everything is. I made this whole thing. So when we go over here, I know what I'm looking at. I did all of this. Y'all were here with me, and I did all of this. So I know this is a croissant. I know this is the head. I know this weird thing is the mouth. Like this is the sleeve, and guess what? This is actually two. This is actually two sides. See, there's two of them. Like I know all of this. I did this. I did all this myself. So I don't even know if I need to write things down. I added that as a precautionary, and that was the third step. We did three things. We came up with an idea, we turned it into 3D, and we unfolded it so we could actually color it in. And the next step is coloring it in, making texture, making material turn into texture. Because one of the last steps to do is to import this model. It's going to end up being a FBX, I believe. Pretty sure it's an FBX. Pretty sure. I don't remember. Pretty sure it's an FBX. Yeah, just do it. Just do it. I'm pretty sure it's an FBX. Yeah, we're gonna export the FBX into Unity, and in Unity we could start applying things, something like other things to make it work. The software that I use, VCFace, very popular, common software to use. All you literally need is a webcam, and if you want like a hand tracking device, which is a little expensive, it's like $80. Nowadays it's like $80. And so, you know, we go over here to make these materials, to make the materials, and then we can turn those materials into textures, literally just pictures, just PNGs. And because even though like Blender has its own type of shaders, Unity has its own types of shaders, literally even Unreal Engine, which we shouldn't even be talking about, has its own types of shaders. They work within their own specific engine. So everything I do here isn't going to be imported into Unity. So instead of having all of this generated color for like generating geometry, we could export it as a picture so that it does wrap around the model using all of this. All of this. You know, this again, taking things step by step. Understand the process. So this is where the fun part begins. Excuse me. I mean, I don't even like drawing, so that's kind of true. Kind of true. I don't know if I'm joking. You need to draw in order to model, definitely. Like it's a little bit of everything. And so there are the ones that we'll be focusing on are the base color, the metallic, the roughness, and the normal. Those are the main ones that we'll be working with because those are the ones that we can export as PBR maps. And PBR, look at PBR. What is PBR map? What's the definition? What is a PBR map? PBR maps are physically based rendering maps. There it is. Physically based rendering map. They provide critical information that describes the visual properties, what you see as the user of a surface in a physical, plausible way. Like, yeah, like it's just it's extra wording for not much of any reason, to be honest. In a physical, plausible way. Visual properties, yeah, it provides information. It gives you color, so you can see it. Is what I see. Provide, give, visual, color, and at that point, anything plausible, like, just is. So, like, we can take these 15 words and turn it into 2. Their goal is to inform 3D software of the various properties of a texture so that realistic looking results can be achieved under all lighting conditions. And this is described this way because a PBR map is not just one kind of map. So looking at this thing that I plugged in to create the UVs is a type of map. It's albedo, I think it's pronounced. It's also, I mean, it's color. It's literally color. People say color map, albedo map. You gotta stick up your butt. Like, don't call it albedo. I will, just to sound like a douchebag. And Yeah, maybe cut that part out. Yeah, I'll call it albedo map just to sound like a smart guy. But still, like it's the same thing. This is just the color, but there are other PBR maps. The different kinds of maps, different kinds of images to. They're called maps because they're spread out on this UV grid. This is a map. It tells something where to go. It tells Blender or any kind of literal 3D rendering engine where to go. Shading. So look deeper into this because there are different kinds of maps. Render map is not PBR map, it's specifically to poly. Our AI approximates the final render. This is something called poly. Yeah, so this one we don't even know. This is something. There's something called poly. I'm looking through something called poly, which render map does not apply to what we're doing. It doesn't apply to anything except for whatever poly is. That's where we are. Poly.com. So I'm gonna scroll down so I can't. All right, forget this one. Color albedo. I just talked about this. Literally just colors. You want something red? Well, guess what? Now it's red. And so normal map's really interesting. Normal map will add texture depth and can help create high detail bumps and dents without adding much processing power in the renderer. For some materials, such as clothes, a displacement map is often not needed, saving your graphics and cycle. So this just described two different kinds of maps at the same time. Normal map and displacement map. A displacement map actually generates geometry, while a normal map does not. A normal map will take like visual information and make it respond to light without any extra geometry, without any geometry, literally. So normal maps are very important when making something like a video game or even movies. I mean, those normal maps could be used into bump maps, which like aren't even here. Displacement maps are kind of outdated, honestly. Or bump maps. They're almost the same thing. Displacement maps and bump maps are very similar. But so regarding a normal map, it's like I don't know how to give you an example without actually material. Metal, I guess. Metal is probably one of the best examples. So I'm just going to create giving you examples of what these are before we get started. Non-metal. Metal looks pretty simple. Metal scan. Use metal scan. And to the what's it called? Cast my keys. So here we have the metal scan. I'm using BlenderKit, by the way. It's a free add-on, really useful. You can it imports shaders with already generated, like people made these, and the shaders are free. The meshes are not. All right, look at this plane. It's metal. It's just a color slapped onto a plane. And I'm just gonna make it round because I can. It's easier to see. So best way I can describe it is it has all the different nodes. It has the color, like I said. It has the metal and the roughness, just like I said, and the normal, just like I said. The 4 different maps that we were going to be applying to my VTuber are already applied to this metal because they're all different kinds of pictures. They're all different kinds of PBR maps that are applied to a mesh. And we'll get a little more into it. I need to learn more about this, but that's not even the point. Separate X, Y, Z, the invert factor, 1, 2, Y, combining X, Y, and Z on the normal map, which is this right here, which you cannot see. That's the normal map. This is the normal map. It's right here. This is normal. This is the roughness. Metallic is just like the roughness, except opposite. This is how it works. I'll explain once we even get there. But the next one after the color, right here, the albedo, we're talking about the normal map right here. It's literally works in, I think, 3 different colors. And yeah, so this data, this information, is used for the engine to generate different kinds of reflection using light. So if I were to unplug this normal map, unplug this entire thing, all like this entire mapping up to normal, probably highlight this better, like this right here, and I'll get unplugged by just taking this out right here. Beep. And it's hard to really explain what this is doing because the roughness map is already on it. All right, let's do a step by step. Do a step. We talked about the color. This is a regular old plane with nothing on it. We're in the material preview, so we can see materials. Right, this has got the UV on it, which I applied to it. Like, it's no problem. Like, whatever. And talk about the color already. This is the color. Plug it in. Really just a picture. Where'd I go? Just a picture with proper scaling with using this, which applies to every single one of these EBR maps because it's all the same size. It's all based on the sample UV that, which literally is just this. It's literally just a plane, and it's been subdivided. So it's really basic. This is like as simple as you can get. So we did the color, and now I'm gonna plug this normal map in because that's what we are just talking about last. See what happens to it. So I'll unplug it. Oh man, this doesn't do it. Do you even any point to like this normal map? This is a poor example. Yeah, it's find a different example. Do not metal, maybe 3. Filling up my data with like materials I'm not using. Alright. Pretty much the same thing. They're all going to be doing the same thing. Look, this one doesn't have a metallic. If anything, this one's simpler. Same thing. These orange ones are pictures. Except one of them has a displacement, which really is only used for cycles. I don't even need this. Right? That's a real question. It's not doing anything. I'm not working in cycles. I'm working in Eevee. These different kinds of engines. And so diffuse, unplug the roughness, and we're going to take over this one. Not doing much. Bump the normal to bump. Got 2 different bumps on it. That's an tight, man. This is, I don't need, right? Oh, it does something to it. Alright, I'm gonna plug in the normal map. So this is a flat image. I if I add a light to it. Add lights here? Okay, I'm gonna add a spotlight. There's a point actually. Add a point. Bring it up, got bigger. Okay. So it's almost like it's a flat piece of paper where like, you know, the darker parts would mean that there's shadow. If we plug in this normal map, which really is 2 different ones, and start moving it around again, it responds differently. See, like, the dark parts don't get lit as much as the other parts do. Right? Exactly, that's happening. I'll lower it down so it gets more lit up. The light's right there. Put this back in. See how it responds? Look at this part right here. Right. It's acting funny. Here's the kingdom witness, blood moon rise, yeah. Univo co-president. I'm explaining PBR maps, and I'm not sure if I'm doing a good job. I'm doing a job, for sure. So that's normal maps. And oh yeah, displacement map is often not needed. Yeah, so height, displacement, they're the same thing, described the same way. And similar. So we talked, yeah, render map. This is only applied to poly, whatever poly is. We talked about color, we talked about normal, and now the height map. Similar to a normal map, the height displacement map versus the same thing, height or displacement. This map provides depth information for your texture. However, it creates more dramatic surface depth renderings as it actually adds data to the 3D mesh. This can give your texture additional shading, internal occlusions, etc. Note that for this reason, in a true ray traced render, your textures will actually look better than they do in the poly, whatever this. No one cares about poly right now. I'm not talking about poly. It's nice that this is describing all the different PBRs, but this is about poly, and I'm not talking about poly. Thank you, poly.com. As mentioned, height map does create extra geometry. It's good to use for movies. It's good to use for game engines where it doesn't need all this extra data from the get-go. You know, like Call of Duty or something, where like you're just downloading mesh and mesh and mesh. A good engine. I don't know how Call of Duty does it, but like a good engine would have like, I know Fortnite does it. I know Overwatch does it. Where, you know, like if you load the game up and everything looks like really blobby, that's the actual mesh data that like the mesh artists created. I don't know, the 3D artists, the ones that are in charge of making the mesh, that's how they made it. And there's someone else in charge of the PBR maps, in charge of the height maps that actually almost sculpt this thing into what it really is. It's fascinating how much space is saved because the engine takes all these maps and then applies it when the scene is generated, when it starts, when you're actually playing the game. The game is played, and then everything gets made. The game is it's making the scene with its data. Like you see, that's a whole other story. But yeah. So again, because we're not going to use the height map. We're not going to use the bump maps. We're only going to use normal maps. This isn't going to generate anything else. Working in Eevee, very simple process, as far as we know. And yeah, we don't need the height map, displacement map, bump map. Well, these three words, two of them are the same. One of them is a little bit different, and honestly, a little bit more demanding in processing. Ambient occlusion. An ambient occlusion map adds shadows to occluded portion of the texture with crevices, adding more realistic details. With ambient occlusion, your texture will look less synthetic. Ambient occlusion. This one's a little bit more advanced, but it's another kind of map. Each of these maps, each of these pictures generates data in a different way. I'm surprised we haven't done roughness. Oh, it's right here. They're right there. Next to it right there. Yeah, ambient occlusion, I don't even want to talk about because I'm not going to use it. Ambient occlusion, look it up. I mean, it says it right there, but like an AO map. Oh wait, it's like a color. I mean, this is diffuse. Um, Ambient occlusion map is a grayscale map which contains lighting data. It's not typically used as a phone map and is instead usually combined with a diffuse map to bake in shop shadows. Diffuse is color. Right here. In 3D engine, Most lighting and shadow information in the final display image output is taken from the lights used in the scene. Yeah, so an ambient occlusion map generates its own light on top of like the mesh, for the mesh. Very interesting. So like maybe lighting under the neck, or like maybe if like a lamp that's turned off, the neck of the lamp would be too dark, they would add some ambient occlusion. They would add an ambient occlusion map to make it look less dark and more presentable for the viewer. Okay, that makes sense. Which could be applied to the base color, literally. Honestly, I don't, as a Blender user, I don't really see the purpose of it for making colors anyway. Could be, I'm probably wrong when I say that, but again, as a VTuber artist, I haven't had any need for it. But it makes sense. Ambient occlusion adds light to texture. Okay. Roughness map. A roughness map determines how rough or smooth a texture is and how light is spread across your surface. A fully black roughness map corresponds to mirror-like smoothness, while an all-white roughness map corresponds to a fully matte material, which scatters light in all directions. That makes sense? Let's read metalness map now. Metalness map determines which pixels of your texture map are considered metal versus non-metal. Different renderers handle this map slightly different, but the general principle is that the color map determines the color of the metal, while the metalness map determines the metallic property of the surface. Some renderers can use grayscale metalness maps to simulate partially metallic, e.g. rusty, surfaces, while other renderers rely on the roughness map for that information. See, it's talking about roughness while it's talking about metal. I don't know what metalness is, but I do know what metal is. It's the same thing, but it's kind of silly, if you ask me. Yeah, I mean, anything but the base color. It all has to do with light. You know, like without any light, you can't even see color. But the okay, let's look all these back in. Normal. This is the roughness. This one's metallic. Okay, so mine rendered. Yeah. Oh, that light over. I don't even need any of it. What's so gray? All right. You see how the light is responding? I'm sorry. You see how the mesh, the material is responding to the light. You know, I move the camera up, I'm down, the light is moving with it. And it's not just flat. The rust isn't capturing as much light as like the green paint. And that's thanks to the metallic and roughness map. On top of the normal, but the normal does a little bit differently. To take out the metallic and the roughness map, see how dull it is? You can't even see the light anymore. You can't see that because of the metallic, I'm pretty sure. Metallic does most of the work because this is literally metal. See, now without the metallic, the whole thing is reflecting. And I'm putting the wrong. Yeah. So see how dull this looks without the metallic map? I can raise this all the way up, and now the whole thing looks like it's still metallic. But this map gives it a more accurate look. Rather, it should. It doesn't. Damn, they're up this map. Yeah, so I mean, go back to the wood. And I'll tell you, in terms of metallic, it's really only going to be a 0 to 100. Like, if it's not 0, it just is. Like, there is no 50% metallic. Like, something either is or it isn't. put something in between, it's like, why bother? This is the metallic map. And this is smoothness? Smooth. So it's funny. The thing about metallic and roughness maps is that they are actually pretty much opposite. They work opposite from each other. So if I were to add a color ramp, plug them both in like this, and then put this color ramp into this one, I think, and then reverse these. Now I have a roughness map and a metallic map because they work in opposite. Pretty sure. Pretty sure. No, but I know what I'm saying is true 100%. 100%. It's I forget which order it was, but roughness map works in black and white, and metallic map works in white and black. So, that being said, that was a crash course of PBR maps. It isn't as complicated as it looks. Like, this is just used for like scaling. This is really just used for scaling. These orange ones, these are the actual images that we're using. I added this one, and then we don't even need this one. Because doing this one, we don't even need this one. So it's actually more like this. And I don't even, yeah, height map, height map barely does anything, does it? Oh, damn. Height map's important. Bump map works. Bump map works pretty good. Nice for using bump maps. See, the bump map added detail to the bark. Very interesting. Kind of redundant. What if I put it into the normal map? I'm getting really off topic. Replace like switches over. Gross. Yeah. So the bump map works with a normal map. If you wanted to add a bump to it, so scaling the strength of the bump map, only working in 2D. It looks like it's just applying lighting texture in a different kind of way. Not changing anything, honestly. It's just making some parts darker than others. Funny. Yep. I'm getting distracted. Yep, getting distracted. Go to my Blender file and move. Okay. Out of the way. Why? Okay. Weird that everything is gray. Right. Breaking everything. Oh, you know what it is? Over here. Yeah, okay. Better. Okay. Now, after explaining all of that, it's been like almost an hour, and I haven't even started. This might just be a video on its own, explaining PBR maps in my own silly way. Back to my notes. We're doing textures. We're exporting maps We're gonna do color, normal, roughness, and metal, probably. And things are gonna get messy really quick because I'm going to use most of these. I'm going to use BlenderKit to generate materials so that I can export the textures into a single PBR, just like how we saw with the tree picture, the tree color map, and the roughness and all those things. Okay, apologies. What was I saying? Um, really change gears there. Completely change gears. So we're doing the materials, and with the materials, we had to decide what kind of style we're going to have. The fact that this is so round means we shouldn't be using too much of realistic kinds of materials. Like my guy, literally just flat colors. It's not too good. It's my very first attempt, and I published it, so it's actually pretty good for a first try. But after learning from that, I'm going to start applying materials to, not just materials. I'm going to start I'm not gonna say. I have these themes here for a reason, a big reason, so that I can separate each of these by color. And okay, well, let's start making a list of the different kinds of materials that we'll be using. This side. This side. Cool. I like the wireframe. Uh, so we're gonna write steps at steps at what? Steps at what? At what? At what? Steps at where am I? Materials? Yeah. Steps at materials. So the materials here we have the jacket. I want the pockets to be a different color, which will be the same. It's gonna be the same texture, different color. FERENT, different color. So like same PBR. Besides color. Oops. Okay. All right. Jacket the pocket. Pockets, jacket. The boots. Boots are gonna be black. Boots will be black. The eyes. Parts of the headphones. I'm not so sure about how I'm gonna make that just yet. So the headphones, the buttons. Going from the bottom up. The boots. The belt buckle. Buttons. Possibly a tip of the pen, although that should be metallic, so that's probably not gonna be there. I would save space and time if I don't know. I don't really know. It won't be a big deal. But okay, so the eyes, and I think that's it for black. And um, and then yeah, I'll just write like black over here. Jacket's gonna be white, probably. Question mark. Pockets off white? Question mark. Whatever the jacket color is, the pockets will be like a slightly different color from. Oh, and then romantic. You love Yunobo. Really funny. Yeah, I haven't seen him. I'm thinking about Here's the Kingdom now. I haven't gone to Death Mountain. Pretty fun. I wonder if he's like clear. Or he's just like a. Anyway, we're talking about Blender, and okay. So then there's like the off black. Oh, and the buckle, like the clip. I don't know what color that would be. So we got the pocket, the belt. Okay, so we need the fur. So like hands. We need hands. Face, legs. That's going to be fur color. I want it to be kind of like Dalmatian body. So I have different colors, maybe like white and brown or something. And if it not, then like whatever. But we're gonna try that out. We're gonna figure that out. And all right, we got the fur and the pencil. So the pencil's gonna have its own pen. It's gonna have its own. The teeth, the mouth. Okay, so looking for the paws. We're looking for the ear inside inner ear. Oh, that's true. Hands, face, legs, ears. Pen, pencil, paws, inner ears, the nose. What else can be like that like pinky kind of color? The mouth wants to be a darker color, so the mouth doesn't have its own mouth. This one like pink mouth. Oh, dark red. Pen, pencil. Uh, yes. I want to see. All right, pencil's orange, wood, and what's this one? Graphite. All right, so pencil is orange paint, wood, and graphite. Pen is like silver and black metal. And so, yeah, probably just silver and black. So, like, a pen is a pen is a pen is a pen. I think that can be fine. How about that you had headphones? Jacket, boots, pockets, headphones. Right, shorts, much. The front t-shirt. Short. Front shirt. So I said, front short shirt, front shirt, and tape. So the front shirt, I don't know. Probably have the same colors for the. I don't know. I'm thinking orange, honestly. And the cape. red, I guess. Like, who wouldn't have red? I mean, we'll figure it out when we get there. The point is to have different colors and making sure we don't give too many materials. Like, this is going to be a lot, but at the end of it, we're going to have like 3 or 4 different maps. You know, once I like mold everything together. That part is I'm going to record it, but I won't be streaming it. I'll be doing it on my iPad, and I'll figure that out a different time. But for today, we're just getting ourselves organized. I'll be back tomorrow. So, oh, the lens. Lenses. Lenses is blue. You know that, like seafoam green. Seafoam green. Teeth. Teeth are white. Super simple. The nose, the face, the eyes, boots, eyes. Headphone, the head, the croissant. Wow. Hang on. ROI. The biggest thing on the entire mesh is like one of the last things I wrote. I don't know. We'll figure this one. Probably shaders. If not, we can just find a picture on the internet and then just like slap it over there. But honestly, the problem with the croissant is that it has 2 halves to it. So I'll have to figure out some kind of way to locate where I want the different like cooking color to be. But this line here is because I want it to be different. Buttons, pockets, pens, pencils, buckle. Yeah, so I think I'm gonna have this shirt be orange, maybe red, and then the cape would have to be like the same color. No, because the cape will start around here, I think. So yeah, I'll have the shirt be orange, then I'll have the cape be red. And on top of that, the front shirt, orange and cape. Wait, what? Front shirt and cape, red and orange. I'm gonna have a croissant. I have to draw. Again, something I will record, but not stream. And it'll be like one of the last things that happen. This might be. Again, the play button. Belt buckle again. It's got a few different parts to it. It's like, oh, and the belt. I don't even know what the color I want the belt to be, but the truth is the belt will be made out of like the type of leather. So whatever matches with orange and red, white, like we can't have too many colors. There's going to be a mess, really. Different shades of orange for the shirt. The shirt and the cape are like the same color. The jacket is the same color. The top matches with the shirt and the cape. The paws is just the organic part to have some like flesh, to have it like glow like a person. The boots, we're not going to see the boots, but it is black in fact. So I think the pants. I think I'll end up making the belt match black with um I'll have it match black with boots. Okay, so belt. This one's a belt buckle, so the belt buckle a little bit different. It's outer metal. Capital. Outer will be metal, and then the inner orange or something. Inner, outer would be, well, all metal. Okay, try that. All metal, comma. Outer will be like a red, something. And the inner will be white. Pants are pants. Pants are pants. Like, you're just gonna make them like jeans. Or, well, the shorts, honestly. Homie's wearing shorts. And, to match everything else, the fact that he's wearing a jacket or type of cape. Colors are not entirely confirmed, but the truth is the shoes are black. And if the shoes are black, everything else have to match with the fleshy. The pants would have to be like a light, friendly color. This is my original concept of it, but back then he had a lab coat, and now he doesn't. I turned him into like a cape guy. Build the croissant in the front, croissant in the back. Jeans will have to somewhat match the top, so I think gray is like the answer. But I don't like that. It's kind of boring. Uh, I'll give him like dark blue, I guess. That's a pretty like denim. And the same thing with the pockets. Jacket and pocket. Pocket. And same PBR besides color. I spelled besides wrong. Oops. Pockets off white. Boots, eyes, headphones, black, belt, buckle, black. Yeah, different shades. Because, well, the headphones can't just be all black. And like, there's this foamy bit here, which will have to be like a gray, like a shade of black. And as I mentioned with the buckle here, I don't want this whole thing to be black. I want the boot to be black, but then I want these to be gray. Totally doable. So, pen, pencil pants, boots, legs, part of skin, hands, face, legs, ears. About the tongue. Out. Tongue. Pick up pink. Yeah, so we have seafoam green for the glasses. Each of these needs to. Everything can't stand out at the same time. The thing that needs to stand out are the croissants, the ears, and the eyes. Headphones will end up being like a really neutral color. And what also will really pop out is the croissant on the shirt. Because everything else needs to be kind of like I can't say flat, but I will say like same-ish. They might just wear like light green colors, different shades of the sort. Like light green. I'm feeling like this color right here. Light green, orange, and black. Colors. Light green, orange, and to be confirmed, Well, light green, orange, and black, and then the fur. Which would be more like yeah, two opposites. Two kinds of opposites, which leads to about 4 different colors. Um we have light green. Orange will be here, the croissant will be orange. Jacket. Well, it's all right here anyway. We can have the jacket one. But no, I don't want. But the main character is white. The side character would have to be like green. Yeah, green is the answer, honestly. The jacket needs to be green. Alright, no, we're making the jacket. That's true. Alright, that's a good start. Because with that we can do everything. And then the main shirt will end up being like blue or something. Probably a turquoise. Think about drawing truckers front shirt. What did I say? Blue? Like in blue? Deep red. Red whatever. Make. So if it's red it'll be hard to contrast with the croissant. Like that's gonna be the issue. This one orange. Maybe. Blend, seafoam green. Jacket may as well just match with. Yeah, I think this is good. Gonna. Okay. Wait. Okay. And yeah, so this stream is really mostly about getting the materials introduced. It is a handful to understand and consider. I didn't even get much done. However, now that we have an outline of how to get things done, the next stream will actually get this going. And with that, I'm done for today. I'll see you guys tomorrow. Noboko President, I appreciate you and I love you. You see me every time. Thanks for sticking around. Everyone else, including Novo, Princess Zelda, enjoy the rest of your weekend. I'll see you tomorrow.